So today we are going to be discussing instructions for a computer. Now, generally speaking, as a matter of fact, I can't think of any that fall out of these categories, but there are four categories of computer instructions. Arithmetic, which is your plus, minus, multiplication, and division. Most computers, most processors can only do those four operations. More complex operations have to be coded in software to break down into those four operations. Then there's logic instructions. That's your and, or, invert, and XOR. That's usually the extent of what is available to a processor. Finally, then you have your flow control, which is like branching. On the processor level, most processors do not have a for loop or a while loop in the instruction set, so you have to create those using flow control and logic statements and building them that way. And then finally, there's moving data. Now, moving data is what gets things done in a processor or in a computer. For example, if you put a particular number in a particular memory address location, it will show up as a dot on the screen, a pixel on the screen of the color that is represented by the number in that memory location. So moving things around on the screen is just moving the data to and from the appropriate memory locations in the computer. Likewise, if you want to send something out on information out on a USB port, you put it in a particular memory location, and the USB hardware will automatically take that data and send it out on the transmission line. That sort of thing. But yeah, instructions for a computer just fall into these four categories. Pretty simple. There's lots of variations of each instruction, but these four categories are about all you need in a computer. Now, a computer, the vocabulary for a computer is very limited. Most laptops, at least before Apple started making their own processors, most laptops use the x86 64 instruction set. Apple Silicon uses the ARM instruction set. But the x86 instruction set only has about, depending on how you count, 1,000 to 3,000 instructions. That's it. Now, it might be a challenge to memorize all those 1,000 or 3,000 instructions, different instructions, but that's fairly limited. That is for, these are CISC processors, which means complex instruction set computers. So that's about as complex as they get. 1,000 to 3,000 instructions. For RISC processors, like the AVR family, the AVR family, if you're familiar with Arduino, they use AVR processors. This is an AVR processor here, this little black square here on this board. They're a reduced instruction set computer. Where is it? Okay, 100. I thought so. 124 instructions. That's it. Much easier to learn. Each instruction does a little bit less, but definitely within the realm of easy to learn. For a RISC processor, complex instruction sets, a little bit less so. But all this is in comparison to English, which the Oxford English Dictionary has over 600,000 different words. And English is what we speak every day, and it's, we've learned that. Although most people's vocabulary, most adults, their vocabulary is in the realm of 20 to 35,000 words that you use actively every day. Now, you might recognize more words, and your passive vocabulary, words that you recognize and know the meaning of, but you don't use in conversation or in your writing, that can be upwards of 60,000 words. So when you get right down to it, we only use or recognize about 10% of the English language. And that's enough to get communication across, usually effectively, to other English speakers. Highly educated individuals can have a passive vocabulary into the range of 75,000 words. And you are well on your way to being in that category of highly educated. Most of what we don't use in English is are words that are archaic, obscure, or specialized. And going to college and studying a particular topic, you learn a lot of those specialized words. So at least specialized for the field that you're studying. But which would you rather learn? 60,000 words or 124? 124, that's a piece of cake. I mean, that's, learning the vocabulary in elementary school a few weeks, so that's how simple the vocabulary is for processors. Now, when you get into higher level languages, this is all assembly language, which is just one step above machine code, the ones and zeros that the machine actually processes. There's a one-to-one correspondence between the 124 instructions in the AVR instruction set to the ones and zeros that what's called opcode that the processor actually runs. So what about higher level languages? You think they have more or less words in their vocabulary? Less, yes. C++, which you study in CS1 and 2, has 97 keywords. Just 97. That's your vocabulary for the entire language. Now, to be fair, C++ also uses symbols and various punctuation marks to take the place of some keywords that are in other languages. But as far as words are concerned, 97, that's it. Java, what they taught for CS, the computer science students back when I was here, only 51 keywords. Considerably fewer, just a little over half. Python, 36. With Python, though, you have built-in functions that are always available. They don't have to be imported in some library. and that number is around 70 built-in functions. But yeah, just 97 words for C++ and 36 for Python. Not much to learn. I liken computer instructions, the few that there are, to bricks. A brick is a simple shape, rectangular prism, technically I think is the term. But look what architects have been doing with bricks for thousands of years. They make complex things out of simple shapes. These simple words, these simple examples of words, likewise can be arranged in amazingly complex ways to create the variety of things that you see on the computer screen, or printed out, or come out through the speakers, that sort of thing. So the instructions for a computer, very limited, but with creativity you can create all kinds of complex programs and results. But like I said before, on Monday, these last few lectures before the end of the semester are going to be very brief. This is probably one of the briefest lectures thus far, and probably from here on out. But I am working on getting the final written up and ready for you for after Thanksgiving. We have, 4 more lectures left? So just winding things down. I'm not going to make things tough by cramming all kinds of obscure, abstract ideas on you in the last few weeks. Let that go to your more advanced classes. But have a good day.